Hello everyone, and welcome to part 4 of the Streamline tutorials series. From part 4 to part 7, we will be covering how to build more advanced and more practical systems using Streamline. These are a preview of the systems we will be building from here on out. Today we will be focusing on Fireworks, but first let's get a quick overview of what to expect from the rest of these tutorials. So this is the Fireworks system here. And it's harder to see because it's daytime right now, but they launch up into the sky and explode, and we use splines to influence their bursts. This second system here is using a spline to clear out a cloud of particles. You can see there's all of the particles just floating here, and then the spline kind of turns on and pushes them away from it. Third is a basic magic attack that uses splines to choreograph it, and it just projects out and hits a wall. And fourth, this is Streamline being used to influence particle spawning for Niagara fluids. So Streamline does work with Niagara fluids just fine. Niagara fluids is really no different than any other Niagara system. It's just rendered differently. And so what this does is this system creates trails of fire kind of along these splines here. But with that being said, let's get to making some fireworks. Okay, so first things first, if we're making some fireworks, we want to be able to see them. So let's get the directional light here. And let's just make the sunset real quick. So now it's dark, but we have these lights here on the side so we can see what we're doing. Anyways, so if we look at these fireworks, we can see on the ground, a little hard to see with all the white, but if we look at them from this angle, we have this kind of chaotic looking spline over here that drives one of the fireworks. We have just a simple little V over here, and this drives another one of the fireworks. This is the orange firework. This chaotic spline is the blue firework. And then this star right here on the ground, the star spline drives the green firework. So this actually drives the shape of the firework itself here. And then when we watch a launch, you can see it has a trail, launches up into the sky and explodes. And each of these fireworks has different characteristics, although this is still coming from the same emitter. So we'll be building a multi-purpose firework emitter today, with all kinds of different user settings, so you can tweak how your firework looks, and then you can use the spline to determine how it will behave. So you can either have different particle movement in the sky like you see in the orange and blue fireworks, or you can have a shape spawn from it like you see in the star firework. So first, so we can get an idea of what we will be doing, let's take a more detailed look at one of these Niagara emitters that uses Streamline to see what we're dealing with. So if we go to our Niagara system here, we can open it up, and we can see that there are going to be 6 different emitters in the system here, and each of these plays very important parts in the system setup. This first one is the rocket itself. This is the individual ball of light that shoots up, usually seen at the forefront of these trails. And then the second part is these spirally trails that actually follow this rocket, which is seen right here. And then we have the burst, and we also have trails on the particles of the burst. And these are more or less duplicated to create the shaped version as well, and these just sample differently from the input spline so that you can get a shape instead of the spline defining the behavior of the particle. So, to get started with creating our firework system, we can go to our content browser and create a new Niagara system. We can just use a fountain for this. None of the templates here for Streamline are going to really help us with this. This is going to be a system made completely from the ground up here. So we can call this Streamline Firework. Streamline Fireworks Effects. We can open this up, and we just have our basic fountain right now. But what we will want to create first is the firework rocket. And to do this, we will need to make sure that this is a spawn burst node, since we only want to spawn one rocket at once every time the system cycles around. So we can get rid of this module here, and we can put a spawn burst instantaneous module in the stack. We will only want one particle to spawn, and we will want it to spawn instantaneously once the loop says it's time to spawn. And for this loop, we will want to make sure it's an infinite loop so it can repeat. You can change this if you only want your firework to fire once when prompted. You can change it to this, or however many times you want. You can do multiple. And for this loop, we will want to make sure that this only fires occasionally still, but still loops. So if we look here, you'll see this particle shoots up and falls down. And then the moment this particle dies, a new one spawns. And we don't want that. We want there to be delays between our fireworks. Otherwise, the moment one firework explodes, we will have another firework launching off at the same time. And most often, visually, that will not provide a good enough delay to really appreciate the firework. So for this system, what we will do is we will turn on loop delay. And to make this really customizable, we will create a new user exposed parameter. We will make this a float, and we will just call this delay. And we can plug this into our loop delay here. So now our system will stall by this delay amount between loops. And also we might want to turn down the system loop duration here to something like 4, just so it doesn't have odd timings. If we keep it all even numbers, it will often be better here. Okay, now you might be wondering, accessing these through Streamline, how exactly does that work? So first, let's go into here and place down our Streamline emitter on our fireworks pad we have here. We'll place this down. We will just use the default spline for now. Doesn't really matter. So we can put in our firework system, and we will see it's just spawning in that one particle, dropping, spawning, dropping, etc. But it's still doing the thing where it spawns. So we follow this, moment that dies, another particle spawns, another particle spawns. To access our variables for this system, we can just go down to the emitter component of this Streamline emitter. And if we scroll up, we can see the user parameters section, and here we can turn on our delay. This can be something like 4. And so now it will wait 4 seconds in between each spawn. So it jumps and it's gone. 1, 2, 3, 4. And then it jumps and it's gone. So this is a bit closer to something for launching these with the delay that they have. So you can see it's a long delay before the rocket spawns. Okay, so now that we have that, let's actually make sure that this particle goes in the correct direction we want it to. First of all, we'll notice on our firework rockets, we don't want them to have gravity if a firework falls back down to the ground. In most cases, that's not really useful for visual effects. You may want that, especially if that is some mechanic you want to create. But for this case, we are not going to be using gravity, nor do we need drag. And our velocity, this works, it launches it upward here, as we can see in the preview. And if we check out here, it will just launch it upward. But that's not very fast, and we can't control where it launches either. Oftentimes we will want to aim our fireworks. So to fix that, let's reset this velocity here. And we can change this to just linear velocity, so it will just automatically shoot in this direction no matter what. And what we can do is we'll want to specify a vector we can shoot this along, and then for how high to shoot it. This way we can finely tune our fireworks system for however we want to use it. This will require 2 more user parameters, and we will need to basically have a direction vector and multiply that by the height that we want over the entire lifetime of the firework to ensure that we kind of get a distance per second metric of how fast we want this firework charge to be flying. So we can go to multiply vector by float. This first part will be a vector user parameter, so let's go make it over here. So we will just use vector and we will call this direction. So this will basically be a vector representing the direction we want our firework rocket to travel. We can plug that in right there. And then for our float, we will want to have a divide input in there. And what we will want is we will also want to specify how high we want our rocket to fly. So this will be a float variable here. We can call this height. And we can plug this in right there. And we also want to make sure it flies to this height at the time that it dies. So in this case, we will want to add in a lifetime variable as well, so we can determine how long our rocket will live, and then it will reach that specific height right when its lifetime runs out. And of course, we want to make sure this lifetime will apply correctly here, so we can directly set the lifetime to this variable as well. Now, if we go out here, we'll see we don't have too much happening right now, and that is because our direction in the system is set to 0. So we go to our emitter here, and we look at this direction. So if we wanted to fire straight up, we'll just put in 1, and its height and lifetime are 0. So right now, let's say we want our charge to last 2 seconds, and we want it to fly up to a height of 10,000 Unreal units, or centimeters. Now, we see it flies all the way up and disappears. And then it will wait a bit, and then it flies all the way up and disappears. So this is a good start. And what we can do to make this charge more visible is we can go to our color, and we can actually blast its intensity here and make it glow more. So for instance, we can have a bit more red involved in this, so we can make it a bit brighter there, and we can also add a bit more green, so we get kind of this more orangey cream glow to it. And when we compile this, we look here, it's glowing a little bit. Now all we need to do to make it glow more is we just multiply these values even more, but still maintain that same ratio, so we can multiply these by 2. Try out 3. Starting to glow a bit more. And of course, you can make this as intense as you want. We can make this 40 and 30 here. This will make it more of a bright yellow. And if we look, wait, and it launches, and we can see it's got more of a halo to it than before. We can deselect it so it becomes like that. We can just see it launch up like that. It's still a small particle though, so what we'll want to do is just make its size something like 25, and then it will become pretty visible. We will not need to worry about the mass of the particle, and mesh and ribbon attributes do not matter either. So we can save this system, and now we have a bright rocket, kind of yellow colored, that launches into the sky. And the best part is, if we go here, we can go to our emitter, and we can change its height, lifetime, or how long it takes to fire. So you can see if I set this delay to 0, how quickly this would fire. It fires, and then it dies, and then it would fire. And if there's a firework going on up there, particularly with delayed effects like this, that's going to be too much all at once. So we can set that back to 4. We can angle the direction a bit so we can have it shooting at a bit of an angle here. So if we want it shooting a bit to the side, a bit to the right in this case. Now it shoots a bit over than that direction. And this will kind of be the forward and backward in this perspective. So we can have it shoot a bit towards us. We can have it shoot a bit away from us. And now it'll shoot that way. And that is the beginning of the firework charge, and we can also determine how long it will live. So we can do this here, change it up to 5, and we'll see it does launch a little bit slower now because it's taking that lifetime versus the height. So you'll want to adjust either your lifetime or height accordingly so you can get that correct speed that you want it flying away at. Or if you want your fireworks to be slow, you can turn up the lifetime and it will reach that same height, just slower. For now, we will set that back to 2. And our firework rocket is all finished. Okay, so now we have a rocket. The next thing we'll want to do is get these rocket trails that we see on the rocket. And so the way that these work is we take a location event from this, we need to rename it to something like rocket or firework rocket. And we will need to generate a location event here so we can track where this particle is and spawn other particles based off of it. So we will need to add our location event. So we'll go down here to generate location event. Something important we will make sure we want to do is turn on persistent IDs. This way it can track these particles. That will get rid of the errors we see there. Now that we have this, we will need to create a new emitter. We can just have this as an empty emitter here. It's going to be pretty simple. We'll just need more sprite renderers at the bottom. And the particle update, we will have our emitter state. Throw that in there. And this will just be based off of this with a loop duration of 2. And what we'll want to do for this in order to get this system to contact this system is we will want to add an event handler stage. And this way we can pick up the location events and we can spawn particles based off of that. And in our event handler, we will want to set our event source to the firework rocket location event. And every time it generates this event, we will want to spawn usually just one particle here. You can make this more if you want, although it's usually going to be pretty redundant with the method we will use for spawning these. So once the particle spawns, we will want to initialize the particle. We need to worry about this right now. So one other thing I forgot to do here, we don't need the shape location. That doesn't do too much in the system. We can honestly ignore it. Once we initialize the particle, we will want to add velocity to it as well. And obviously we will want to fix these and make sure that the velocity module is all happy. So we will want to add linear velocity here. And these particles will basically be falling off of the rocket as it travels up. So what we will want to do is we will want to make a custom vector here. We will want our Z component to be 0 because we don't want these particles flying down super fast or flying up super fast because they're being propelled in neither direction really. What matters is the X and Y. We kind of want them spraying out in a random spread. So it makes 2 random range floats here. And these can be -100 to 100 on both here. And that is our X and Y velocity right there. On particle update, we will want drag and gravity. And the default settings on those should be enough for this particle. Now what we want to do is we obviously want to save the system, and then in initialize particle, we will want to make sure that these particles also glow pretty similar to our rocket here. So I will just copy this color and paste it right here. I might turn it down a bit from the yellow because it seems pretty intense right there. And what these particles will do is as this rocket takes off, it will have these particles spiral off of it. So what we need to do is, first of all, we need to allow this position here to be set because we will be using this to determine how these particles spiral. It will be using just a basic sine and cosine oscillation to create kind of a circle that the particles spawn on over the lifetime of this emitter. And we will also want to make sure our sprite size is set to something random, like 7 to 12 probably. That will be nice and random. Mesh and ribbon we don't need to worry about. So what we will do to make this position work is we will need to add 2 vectors together. We will need to add our oscillation vector for its position around the rocket, as well as its normal position that it would get from the firework rocket. So for its oscillation, what we can do here is we can make a vector. So X is going to be our sine value, and Y is going to be our cosine. We can ignore the Z because we don't need to spawn these above or below our rocket. So these can have a scale of something around 15 to spawn roughly around the edges of that rocket. And we want these to rotate pretty quickly, so we'll give them a period of about 0.05. We can put that right there. right, so we have the oscillation. Now we need to add this onto the position of the firework rocket as well. So we will create our velocity similar to this. So we can just copy this for now, move it over to here, scroll down, paste this into B. The only difference is instead of the lifetime, we want to use our emitter loop age instead. And then we also want to make sure our own lifetime for these particles is set to something, probably a good random range, something like 0.2 to 3. That way we can get some particles that fizzle out pretty quick, but others will fall for quite a ways. And then also, this might be a bit big, you can turn it down to that. And finally, let's rename our emitter to something like Rocket Trail. And if we go here, we'll see we still aren't getting particles coming from here yet. It's just this singular ball launching off. And that is because we have forgotten to switch this to spawn particles. So now these particles should spawn. We can turn up this number so we can see more every frame. Okay, and we'll also want to make sure our particles get killed. So we will need to add particle state in here and throw that up at the top. Make sure they die when their lifetime has elapsed. So this way our lifetime can kick in properly. Bring that down to 2. Look at this. Firework shoots off and the particles slowly fade away. Make this fade even more apparent if we add a scale color node or module. And we can just scale this alpha by some curve here. And we can just make this a user curve here and it will be smoothed out. And if we look at this, the particles when launched just kind of slowly fade away into little dots, and it looks like a pretty believable firework trail. Now, one last thing we can add to this is we can add an option for a user parameter where we can control how far up those trails still fall from the rocket. We can go down here to our event and we can kill particles. So once it spawns particles from the event, it will just drop down here and then it will drop down here right away. We can add a switch here basically that will kill the particles if this rocket trail's normalized loop age is greater than some value that we set up here in our user exposed variables. So we can set this and we can call this, it'll just be a float user variable. We can call it rocket trail cutoff. And this will just be a float from 0 to 1 saying, okay, this is the point at which we want our particles to no longer spawn. So they will still be handled, but they will immediately die, so they won't even register. And what we will need to do is go look for our normalized loop age here and throw that in. And so if our normalized loop age is going to be less or the same as this, we will want to kill those particles immediately. Speaking of normalized loop age, we also should actually have set this to normalized loop age so we can get this spawning at the proper height. Save that. And go back and check out what's going on. And we can see once it launches, it's still just the rocket by itself again. So we can fix this. If we go to our emitter, rocket trail cutoff is at 0. If we set this to 1, the rocket trail will now go the entire duration. So it goes all the way up. Or we can set this to something like 0.5. And then once it launches, you can see it stops halfway, but this single particle right up there still keeps on going without trail for what is half of its trip right there. So that has completed our rocket trail. The next step is to make a burst actually spawn from this rocket when it dies. So first, let's go and save our system here. And can go to our firework rocket. And so what we will now want to do is generate a death event. So on the death of this particle, we will want to spawn our firework burst. So this will generate the death event. And then over here, we will want to add another empty emitter. We can call this our firework burst. And we can add our event handler into here, and we can pick up a death event. Let's make sure we are receiving this from the fireworks, and it will spawn particles, and it will also just be rendering more sprite particles. We can go to update. We will want these particles to die, so let's set a particle state right there, and let's set and initialize particle on the particle spawn and the particle update. We will set an emitter state, and that is the scaffolding of what will become our firework burst. Another thing to mention is to make sure that both of these have their persistent IDs checked so that you will always be getting the correct IDs for all the particles. Otherwise, you can get some weird particles jittering around and whatnot. So let's go to our emitter state and make it self. We will just want a loop duration of 1 right there. We'll need to initialize our particles, and we'll also need to add velocity to each of these particles. Go ahead and fix these dependencies right here so we can add solid forces and velocity, probably move that below particle state. And we go here, and this is a firework burst, so it will be from a point, and we'll want to basically just burst it outwards from that point. But first, let's go look at the initialization of these particles. So first of all, we don't want all these particles to live the exact same lifespan, so we can set this to like 3 and 5. And then with the color here, we will want to choose the color of the burst here using the user parameters. Let's just call this burst color here. And we can plug that right in. So now the user can determine their own color right there. And then for spawning this in, we will want to make sure we can add the offset of where the firework actually is. So this is going to be much simpler. We won't need to worry about the lifetime of it. We already know it's going to be at the end of its trail, so we can just multiply the vector and float of direction and height. And then mass is not going to matter, but what will matter is this. We will probably want random uniform, and we will want different sized particles overall. So like we'll want a good range, 3 to 20 should work. And then what we'll want to do is go in here to add velocity. And again, we will want this origin offset to be synced with this. So we can copy this, paste it here. And then this is a local offset, so that way it just offsets it by this much locally, and that ensures consistency among all these systems. And then one other thing we'll want to do is we'll want to give an initial velocity variable a value here so we can track that later in the firework burst. So this will be a particle attribute right down here. And right now we just have particles.velocity, so we will need to make our own particle attribute. This will just be a vector called initial velocity. Now we have this. We can set a new existing parameter. We can set initial velocity here. And this will just be a normalized version of our starting velocity. So we can normalize the vector and go down here to our actual particle velocity. This way we can store the initial direction our particle is shot out of the burst at. And what this is good for is determining things like rotations for particles after that first burst, so they can be arranged properly in their space around their starting point. So next we can go to the particle update here. And first thing we'll want to add is in fact a kill particles module, surprisingly, but this is so that later in development when we create our spline shape, we can toggle between a spline shape burst or just a normal burst. And when we toggle between our spline shape burst, we will want this burst version to turn off, so we'll just want these particles to die immediately. There are other ways to do this, but this is just how it's going to be done here, just so it's much more easy to see like this. So we can just create a new boolean here, and this will just be called use shape first. And so when this is checked, we will kill these particles. It's pretty simple. So the next thing that you will want to do here is we will want to actively set our velocity to a specific equation here. Instead of just letting gravity handle it, we will want to make sure that we do set this to something specific. And then after this, we will actually have gravity, and then we will have drag kick in. And this drag, we can probably turn this down. We won't need rotational drag. And we can turn this drag up a little bit, so that way the burst kind of hangs in the air. Like when you see a firework explode, the particles coming out from it explode, but then they hang in the air for a bit before they start to fall. So that's what this drag kind of does, is the particle will have the initial speed coming out of the burst, but then it'll slow down and then it will start to fall. That's what this is for. But most importantly, we need to get this velocity working. So this velocity will be determined based off of a spline that we draw on the ground. So this will give particles their unique behavior after the burst. So this is where the streamline part of this system actually comes in, is we'll be using the splines in the ground to determine a velocity path for all of the particles to take. So this way, a spline gets sampled and we take the direction on the spline, and we use that as a way to augment a particle's velocity after a firework burst. What we'll want to do is we will want to add the old particle velocity and whatever new velocity we're sampling from the spline. So to get this, we will need to multiply a vector, and we'll want this bottom piece here to be something significant, because otherwise the velocity change from our spline will be hardly noticeable. And then next we'll want to get our spline direction here, and we can, as usual, just leave these two things blank right here. But for our spline U, we are going to use our particle's normalized age here. So this way we can get a point on our spline relative to where the particle is in its lifetime. So this is a good start. And in order to see this, we can go over to our event handler and we can have it spawn, let's just say 150 particles per burst. You can make this a random spawn number. You can really do whatever you want with it. But if we follow this now, you can go see it goes over there and it explodes. And we see this mass of particles shooting out this way. So this is a good start. However, all the particles seem to just follow one direction, and then they even collapse back down to the same point. And they're just following our spline's velocity right here. But these particles aren't exploding in the full burst that you normally see with a firework. And that's because these particles are not having their velocities rotated by the direction they are around that center point. What we need to do is we need to actually create something so that when we set the velocity here, we take this direction, but then we also rotate it by the direction the particle was initially launched from the point of the firework burst. And that is what our initial velocity is here, is we store this direction that the particle is ejected from the burst point at. So what we'll need to do for this is there's no simple way, so we can create a Scratchpad here. So we can get rid of this, and we can go to Scratch Dynamic Inputs. And what we'll want to do is move this out of the way, and we will want to get our vector that is the input. So this will be called it'll be a vector type, and we can call it initial vector. And this up here, we still want another vector, and this will be our rotate by vector. This will be that initial velocity we stored earlier to be the rotation for it. What we will want to do is we will want to take our initial vector and we will do an axis angle rotation. You can learn more about that by looking it up. I won't explain it. It's just a lot of quaternion related mathematics, but basically we can rotate angle on axis This will change that vector to a float. We don't need this. We actually want this vector right here to go on our vector to rotate section here. And then our rotation axis will be about the z-axis, basically about a directly straight up line. And then this will go into our output here. And what we'll do is we'll take this rotate by. This is our initial angle that the particle was launched out of the burst. We can break this vector into its pieces. What we will want to do is we will want to formulate an angle out of this vector. So what we can do is we can actually take an arc tangent here, or an inverse tangent 2, and we want to make sure this does stay in radians because of how this rotates here. This does not take a degree input. If you do, it will be vastly overblown. What we want to do is we'll want to flip these two in our arctangent input, because an arctangent is y over x, since it's the inverse of tangent, which is x over y. And we want a period of 1. We can plug this right into the angle, and that will give us our rotation based on that initial vector we shot from the burst width. You could do this inside of the stack right here, but it's just easier to do it in Scratchpad because it saves more space. So we can go over here to our velocity, and we have our scratch dynamic input. In fact, let's go here and just rename it to something like rotate by, or rotate vector by. And we can put this rotate vector by, so this is our initial vector and our rotate by right in there. And so our initial vector, this will be, again, our spline direction that we got. We can plug that in. Our spline U will be the particle's normalized age. And this time we will rotate by that initial velocity of the particle. Now this, we can save it, and we can watch our firework here. It will get launched. And now we see it actually as a proper burst here. Now it is still launching into a ring. And this is because we have not determined much about our initial velocity except its initial burst x and y. So what we want to do is we want to come over to here, and this hasn't done very much. So we will actually want our velocity speed to be much greater so we can have a much more interesting burst. So we can go to a random range float, and we can do something from 5,000 to 8,500 maybe. Save that, and we see we now have a nice circular burst, spherical burst in fact, in the sky of our particles. And it may not be too obvious right now because our spline is not very extreme, but these particles are following our spline velocity. You'll notice if you follow any one particle, it does somewhat follow the spline shape, where it ducks down and then follows back up. That's what our spline shape does right here, is it ducks. In this case, it would duck up, follow back down. It's really an orientation thing. But this is now following that spline. So what we could do is, if we want to make something like our orange firework, we can take these spline points right here. And what's nice about this is the size of the spline does not really matter. It's the normalized position on the spline that matters. We can take these and we can arrange it into kind of more of a Z like this. And when you look at the burst, you can watch it right here. And the particles kind of do that wavy movement in the air that you see with the orange one over there. However, that's not all. The orange one has these trails on the inside. So what we can also do is we can make each of these burst particles a parent particle for a whole system of trails as well. And so if we go back to our firework here, we have a firework burst, and now we can add another emitter, and we can call this one the firework burst trail. And in order for this to work, we will need to generate a location event from our firework burst particles. We can send this however fast we want. Oftentimes I set this to 60. That way, if your computer's running at an optimal 60 FPS with whatever you're running, you get a pretty good spawn rate here. anyways, we'll go to our emitter. This will still be rendering sprites, and we will be spawning them from an event handler. This time we will be using our Firework Burst location event to spawn particles. And you can spawn like one realistically for these for now. If you want to turn that up so you get more defined trails, go right ahead and do that. But next what we need to do is we need to get our emitter state working. I need this to just be self, infinite with 1 second. And then particle spawn, we will need to initialize our particle update, we will need a particle state, and we will need a add velocity here. And then we'll also need solid forces and velocity. I'll just move that generally to the bottom. That way I never forget to move any physics calculations above it. So we have these particles spawning on the burst. We need to make sure they are in the proper location. And so first of all, we want these to have some kind of random life to them to make them seem more interesting. And then we will also want them to be the color that the user decided for our firework burst. We can make this our burst color here. And then we'll want the size to be something random, so honestly 5 to 10, just the default there, should be good. And in this case, we'll want to add our velocity, and we'll just want to do something pretty small, just a random vector. And this can be -10 to 10 on all of these. And that's really it for how it spawns right there. And then we will just have our particle state. We will have gravity. We will have drag. And we will want to scale its color. And this is something we also should do on Firework Burst 2, is scale the color. All we need to do for these is you don't need to scale the color itself. Ultimately, we need to scale the alpha. We can just do float from curve, and I always make it a smooth curve. It just looks better than linear. It looks more natural because in nature, the fireworks glow from the heat. Nothing that has heat cools off in a straight line. If it has heat, it cools off in a curve. So we can copy this, we can move this over to the other scaling alpha here. And then we also want to make sure we grab the location event here, and we can apply all of this. And so, we can see in our little window here, it is starting to work. If we go here, and we look at this, it'll burst, and then the trails more or less follow those particles. However, they kind of fall pretty weirdly, so what I'm going to do, I'm going to change the drag to random float from 0.5 to 3. That way they have more interesting drag on them and they don't just fall away immediately. And also what I'm going to do is going to save this. I'm going to go to my fireworks settings here and change the burst color to something more interesting. Probably a bright yellow. What I will do is I will take these colors and then multiply them by something like 5. And then it'll take off and explode. I see we have a nice burst here. All those colors. And if you want those trails to fall off faster, what you can do is we can just move this scale forward a bit and they will fall off quicker. Or you can add another key in here and have it fall off a little steeper. That way you'll still get something, but it won't be so bright still. And another thing we can do here is this is just another trail. So we can follow something similar we did for our rocket trail, where we can just add a parameter to kill the particles after a certain amount so they don't follow the burst particles anymore. So we can call this it's just going to be a float and call it burst trail cutoff. And we can just add our kill module here again. We can kill the particles using a Boolean switch. And so what we can do is, we can't just take the lifetime of this emitter, that won't quite work here. So what we can do instead is, when we put in our burst trail cutoff, we put this in as B, and we can instead take our lifetime we get from our event here, or our normalized age, and this can be used in our kill particles. So if we go down to our module outputs, we can do receive location event. This will be float 1. And then if this is greater than this, we will cut it off. As we can see, the trails have gone away in our inspector. And if we go back to here, those trails are gone, but then we can turn this back up to something like 0.8. And we will get trails for most of that, and then they kind of just stop and the particles still keep on going for a bit. We can turn this down to make it even more obvious. We can do like 0.3. They'll have trails in the middle as they burst, and then the trail will disappear. The trails, and then it's gone, and then the actual burst particles are left on their own. So that is how you can create the basic firework using Streamline, and have the spline influence its velocity in the air. However, there's more you can do. This is a start, but what if you want to make shapes? To make the shape ones, you can actually extend this pretty easily. All you need to do is, you can duplicate these, and we can call these, instead of firework burst 001, that's going to get confusing really fast. We can call this firework burst shape. It's always good to make sure that you have these named well, so you never confuse yourself later on in development. Because if you come back to this later because you find you need to fix something, and then you just come back and everything has zeros and ones, you're not going to know what does what. You need to give it a more meaningful name to make sure you understand what's really happening. So with our shape here, when we are initializing this, instead of detecting if it's that, we will want to make sure it's just a not on the exact same variable. So this way, if it's not the use shape burst, it kills these particles immediately. And obviously we'll get no trail after that. And that's one thing you also want to make sure that all of these are hooked up to the correct properties. So for example, we don't want firework burst there, we want our firework burst shape location event. And then the trails here will still have the exact same particle depth offset you can add. But what we really want to get around to doing is actually making this shape work. So instead of initial velocity here, we will not need that. What we can do instead is we want to just set our velocity directly there and have it be a burst. And since we were not going to be modifying it at all directly after the initial burst, so we can get rid of this. We'll still be using gravity and drag, however. And what we can do is we can go to our initial velocity. We will not be using initial velocity, so we can get rid of this. In fact, we can just remove the parameter entirely. However, we will be setting the initial velocity in this section. But first, let's replace this module with a shape location spline module. This way we can get our spline shape, and then we can basically project it into the sky. And so to do that, we'll want to make sure we have a uniform distribution, so we can uniformly distribute all of our burst particles across the spline. Right now we're using 150 from the burst down here. And we want this across the entire spline. You can obviously go ahead and change this. And we'll want our transform to be slightly different. This will really depend on how your spline is set up on the ground. What I'm going to be doing is doing a little bit of offset math with the direction here. So what I'm going to do is I'm going to multiply the vectors of the user direction with the height, as I usually do for these parts. And then scale is going to be all 1. Rotation mode, I'm going to want to set this to yaw, pitch, and roll. And you can really use the pitch however you want. I am going to be drawing out the shape on the ground, so I'm going to use a pitch of negative 0.25. And then we'll want to make sure this is just a local rotation, and nothing advanced needs to be worried about here. But once we have that shape set up, we can take the velocity, and what we can do is we can do something similar to what we did with our initial velocity and velocity update, where we will multiply. First, we will have a multiply here where we add a scaling factor on the bottom to its burst, so you can actually really see the effect of the spline. What we will want to do is we don't just want that initial velocity vector because of the way the spline is. We will want to offset the spline shape by some amount so it bursts from the center properly. This will be a per spline operation. Each spline is going to have a different center that you would choose. But we will need to make a vector user variable here called shape center offset. And what this will do is just offset our spline by a certain amount in any direction to ensure it bursts evenly instead of an uneven burst, because it'll still work, but it just won't look quite the same as a burst from the center like you see with the star. What we want to do now is with the shape center offset, we want to subtract our burst height and this minus the particle's current position so we can get where it is in space and assign it a proper velocity so it can continue moving that direction based off of how the spline is oriented. What we can do is we can get our particle's position. This is not ideal. It's going to complain about the position large world coordinate conversion issue. It doesn't make a huge difference in this case, but that is something you might want to look out for and consider some other form of conversion for this. But next, what we want to do is we want to add this shape center offset we made. We'll want to add this with our burst height, which as usual is our direction times our height. Now with this, we can instead have a shape explosion. So as of now, we will see there is still no shape being made yet. We still have this burst. But if I go here, go to the emitter and turn on use shape burst, it will shoot. This won't look that impressive, but that is what our spline does when it bursts right there. And our shape center offset is 0, so that's going to cause some different bursting issues right there with this spline. So what I'm going to do is I'm going to draw out a new spline for this. We go to modeling and draw a spline, and I'm going to draw just a blob really. And go back to selection, we can go to our blueprint here. We can sample this spline and get rid of our spline actor. So now we have a nice circle to start with. And we can see it is truly bursting in the circle, but now it's kind of bursting over to the side. And this is what the shape center offset does, is we can ensure it doesn't burst to one direction or another. And it ensures that we get a proper burst directly outward. And as we can see, our trails are also taking effect too automatically because of our copy pasting. They are still following the circle. So anyways, what this is really now down to is just tweaking the center offset until you get a burst that you're pleased with. If you want it shooting off in this direction, go right ahead. But most often for a shaped firework, you're going to want it to be centered better. Usually this happens because of respect to the origin. So what you can do is you can shift it a bit by this origin, and that will help center it a bit. So if we look now with that adjustment I've done, it's not bursting as much that way. You'll need to turn this way up, I feel, to get that to effect. It's really just playing around with it. There's no definitive science to getting this to work here. Another thing you can always try is rotating spline. Take the spline, rotate it around. Now shoots in a different direction. And also when you're making your burst shape, you'll want to make sure that you set your simulation position back to 0 just to avoid any further confusion. Now, as we can see, it's bursting out a lot. Now this is where we can draw that X in and reduce how far out it bursts. It's bursting too far that way, so we need to bring it in. Still too far, bring it in a bit more. Not quite enough. And there we go. Now that bursting in a shape, it's pretty high up, so it's hard to see. I'm going to straighten it out and bring its height down a bit so you can see it better. That's another thing. Changing its height will change how it bursts. So as you can see, this is kind of making a trumpet-like shape. If we adjust it more, it can explode directly out. You can probably pretty easily just make an equation to do this for you instead of having to manually adjust it, but for the sake of this tutorial, we don't want to just jump into too much math. We want to make this still pretty accessible for some of the non-mathematically inclined. So again, somewhere in there is the sweet spot. And almost there, maybe 1.9 or 1,900. Boom, there we go. Now we have that perfect shape burst that we're looking for. It's just a blob on the ground. But you could make this anything. I mean, I could go ahead and sample my other star I have over here and turn it into something that looks much more interesting. We can sample this. Now we have a nice little star again. Obviously the star's upside down, but you know, this is just a matter of rotating it. And it's just going to burst, but you can make any shape you want with this. Again, it's just a matter of playing with the controls that you're given here until you find numbers that work for you. We can turn this delay back down to something normal again so we can see what this would really look like instead of the trail hopping in and out. But we will get this shape up there. And again, for some of you that are more into math, I'm sure you could easily figure out an equation that would basically just mix those offsets and rotations no matter your position to get something where it will stay consistent. But we're not going to dive into that here. And now one last little thing that's pretty fun for these is if you look at the particles from this firework here, wait for a burst, you'll see that if we follow this particle right here, it starts blinking in and out. And you can just add twinkling to these particles. It's pretty simple. If we go to our firework burst here, we can go over to our scale color, and we can just make this switch and say if we have a boolean here, and this boolean is something like sparkle, and instead of this float curve, we will save this, but we can do a custom float from bool, and this boolean can say, hey, do we want to sparkle? So if we don't want to sparkle, we use this old curve map here. If we do want to sparkle, we can paste it here, and we can define a sparkle sequence for our particle. So we can just add a key, and we can just have it kind of bounce around really in there however you wish. And that can be your sparkling. And set that to 0. Bring this one down to 0 as well. So now for about half its life, it will stay steady, and then in the end, it will start twinkling. So if we look up at this right here, you can see they kind of start twinkling in and out. A bit hard to see, but again, you can turn this way up. You can even blast these values really, really high up so that it becomes super obvious. And you can also change the size of your particles to make it work. Finally, let's rename this to Firework Star. This is just a star. And what we can do is we can just go and add in another system really easily. And now this is made much easier because we can just add in these systems pretty simply. Obviously, this is just blowing up right on the ground because we have no timing at all for it. So we can go to our emitter and we can have it give it a delay of 4. We can give it a height of 10,000. Bring it up to 1. We can give this kind of a reddish magenta here. Make this live for 2 as well, 2 seconds. Trail cutoff, we can have trail go the whole way. First trail cutoff, we can have also the whole way. We don't need to worry about those. We can also have this one sparkle if we want. And now, you can see it launches. And we have our magenta firework here that follows the patterns we described. You go into play mode here and get an even better look at it once the eyes adjust. And that brings us to the end of the Streamline Firework tutorial. Thank you for hanging in there and creating this wonderful firework system. If you found this video helpful or informative, please don't forget to leave a like, and also go ahead and subscribe to the Galacticc Games YouTube channel to get any information and updates from us. And also check out our Discord community as well to engage with other people using products such as Streamline and creating systems such as these. I hope you learned something today and that you can take this knowledge with you into creating more amazing Streamline systems. And I hope to see you in the next Streamline tutorial.